Okay, so we are on now.
Hello, Gladys.
Yes.
Hi, this is Abdullah and Amy. I just joined and I apologize for being late.
That's okay. I'm working now, okay?
All right, thank you.
Okay, so there are two ways that we sample, two ways that things can be sampled using combined events. So we have these, so you can have these two things happening at the same time, yeah? And they are called independent events, yeah? This one's, because this one is not going to affect that one, yeah? So you can have sampling with replacements, yeah? Sampling with replacement, which is kind of independent. So you can throw the dice, you can spin the spinner, or maybe you can have a bag containing some beads or some balls. Yeah, a bag that contains 3 red balls and 5 blue balls. Yeah, you put your hand in the ball, in the bag, and you take one ball out. Yeah, you take note of the color, you put it back in, and then you take another ball out and put it back in. Yeah, now we can represent that information on a tree diagram. Okay, we can represent that information using a tree diagram, and we start off by drawing the branches of the tree. Let's use R to represent the red. Let me just change the whole thing to black. So we start off the branches of the tree, and we use R to represent the reds and B to represent the blue, okay? So we can have the first time you put your hand in to take a ball and examine it and find out what color it is, your probability of getting a red ball on the first time you put your hand in would be 3/8. Good. And then the probability for the blue ball would be 5/8. Then you're going to put the ball back in, and then you're going to do the same thing again. This time, there are going to be 4 possibilities. It may be that you chose the red one the first time, and the blue one the second time, and the red one the second time, or the red one the first time, and the blue one the second time. It may be that you chose the blue one the first time, and the red one the second time, or the blue one the first time, and the blue one the second time. In each case, the probability does not change because you replace the ball back in and then choose another one, choose another one. So it's going to be still 3/8, 5/8, 3/8, and 5/8. Okay, so that's how you represent it on a probability tree diagram. The word that you're looking for is with replacement, okay? So the ball is chosen, is put back in. So when it's put back in, nothing has changed. It's still 8 balls inside the bag. Then you choose another one, all right? So now you need to learn how, you need to know how to calculate these probabilities. Once you finish drawing your tree, the first thing that you want to do is to draw the probability of each outcome. You know that each of the set of branches add up to 1, yeah? So the first time you put your hand in, these 2 branches, these 2 here will add up to 1, yeah? They will add up to 1. Okay, so So here, then you will then have to multiply this one by this one to get the red and the red. Probability of getting red and red. Yeah, remember we were doing the AND rule here yesterday and the other day. We're looking at the AND rule. So red and red, you need to work out now from your branches. You follow it from here, the first red and the second red. Red and blue will be red and blue. Blue and red will be blue and red. And blue would be blue and blue. Now you need to times them, yeah. 3/8. You remember, and is multiplication, yeah. It's the multiplication rule or the AND rule. When you're doing this and that, you have to times them. So 3/8 times 3/8. Work that out. Let me get the answer. The next one will be 3/8 times
9/64, the first
8.
one.
Yeah. Welcome. Right. So this one, what was this one, Adam or Mahmoud? What was this one?
9/64.
9/64. And this one?
15/64.
Yeah. And then 5/8 times 3/8 here. 5/8 times 3/8 is equal to, yeah. Then you get to work out blue and blue, which is 5/8 times 5/8, which is what? 25/64. Now, if you add all these guys up, add them up, yeah, they will be equal to 1, okay? You remember when we're saying the sum total of all the probabilities is always equal to 1. So they will definitely be equal to 1. Yeah? So if I ask you, what is the probability? Let me write the question out for you now. What is the probability of getting a red and a red? What's your answer going to be?
0.
Have a look at your tree.
Yeah.
9/64.
Excellent, Adam. Well done. Okay, so we've just done that. A red and a red is 9/64. Now, what is the probability? Hang on a minute. Same color. Ah. How would you work out that one?
34/64.
17/32.
How did you get it?
Me?
Yeah, you.
I got 34 out of 34/64. Because it says the probability of getting the same color. So you have blue and blue is 25. And then you have red and red is 9. You add 25 plus 9, 34. And then the denominator stays the same. So it will be 34/64.
Well done. Can you tell the class in Arabic?
الحين عندكم أحمر وأحمر 2 وعندكم أزرق وأزرق الاثنين الأزرق وأزرق 25 over 64 والاحمر واحمر 9 over 64. فعشان هم الاثنين عندهم البروبابيلتي انه يطلع الاثنين نفس اللون، عندك 25 و9 تضيف 9 على 25 يطلع لك 34، والرقم اللي تحت يقعد يكون نفس ما هو ما يتغير. اوكي
يعطيك
بس ليديز.
يعطيك
عافيك.
العافية.
عافيك.
Thank you so much, Adam. Okay, you guys understand it now? Yeah, that's how we do it. Okay, that's how we do it. Okay, so I'm gonna stick one more question in. What is okay, so let me just maybe explain what Adam said earlier to you guys so that you understand it, okay, in English, so that the rest of the world can understand it, yeah? Okay, so it says, what is the probability of getting the same color? And the same color is either red and red or blue and blue, yeah? So listen to the language, is red and red, okay, or blue and blue, yeah? When I was talking about the multiplication and addition rule, I said red and red, you have to times them, okay? And then or is the or rule, you have to add. And then blue and blue, you have to times them. We've already times them here. Can you see them here? We've already times them. That's what Adam was trying to say. So we just take the one that we have times already. That is 9 over 64. And then we add them, okay, to 25 over 64. That's going to give us what?
34.
34 over 60.
The denominator always
The same, yeah? So you can simplify that if you want, or you can leave it as it is, okay? Okay, guys. Let's see. Let's see where we are.
The third question is 15 over 64.
What is the probability of getting a blue in the second draw? Yeah,
15
a
over 64.
blue in the second draw.
40 over 60.
A blue in the second draw is either red and blue or blue and blue, or a blue in the second draw. There's more. Oh, red and blue or blue and blue. Yeah, that's right. Okay. So here
40
or
over
here.
64.
Yeah. So 15 over 64, add 25 over 64. Which is equal to 40 over 64. So your tree is very important. You must draw your tree first. If you haven't drawn your tree, you cannot get all this information because the information is going to come from your tree. Once you've drawn the tree, then you can start to think about how to answer the questions based on your tree. Yeah? Okay. I'm going to put another question. Okay, guys, you got your work to do, okay? Represent this information on a tree diagram. That's my first question. Then okay, that's a simple one for you guys to do. You can do it by yourself, okay? Oh, you're going to my class. What? Check this. I already wrote this in the video. I'll be back, guys. Okay. Okay, guys, everybody finished? Anybody
Yes.
finished the trees?
Yes.
Okay, let's do it now. I'll draw the branches and you guys tell me what you have on them, okay? But be quiet first. Let me finish drawing the branches. Hang on a minute. So, black, green, black, green, black, green. Okay, so what fraction do I have here?
For black, you have 5/9, and for green, you have 4/9.
Have you not mixed them? Black is 4/9.
Yes, 4 is black,
Yeah.
and green is 5/4.
5/9.
9.
Oh gosh.
I still didn't eat lunch, so that's why. No energy.
You're trying, okay? Well done. Right, so how about this one then? Blue and green. So it's going to be the same thing, isn't it? Black,
Yes.
4/9, 5/9, 4/9, and 5/9. What should I do now?
Add them. 4/9 plus 4/9.
Ooh, is it add or multiply? Which one is
Multiply.
it? Another problem again. Oh, God.
You'll put
Okay, so black
BB.
and black.
Yes, it will be
Black
well,
and green. Green and black, and then black. Oh, green and green.
green.
Yep.
It will
4
be
nines.
4/9 times 4/9.
16 over 81.
Okay, and how about this one?
4/9 times 5/9.
20 over 81.
Okay, and this one,
It will be 5/9 times 4/9. It will be the
which
same.
is
20 over.
And the last one,
25 over 81.
16 over 20. 81.
why 16, Adam?
I mix them up.
Okay. Okay, so how do you find out the answers? So you have drawn your tree. So the probability of 2 greens is what now?
25 over 81.
Good. I hope the rest of the class is following. Yeah. So A equals 25 over 81. How about B?
20 over 81.
A black bead followed by a green bead. Yeah, well done. So 20 over 81. Well done, guys. Now I'm going to get you one to try out from the course handbook. Okay, guys, that's your question. Okay, how are we getting on? See, today that the weather is so lovely, it's the day I'm teaching. I'm so sad. I should be outside walking in the sun. I'm not happy with myself. I should be outside catching the sunshine. Oh, goodness me. Hmm. Mhm.
You will do a T diagram?
Yes. Can you not read the question?
Yeah, I know. I'm telling you.
You want me to draw the tree diagram first?
Like,
Okay.
I'm telling you
Oh.
the steps.
Come on, I don't know why that thing changed to red. Who asked you to change yourself to red? Okay, so bag contains 3 black balls and 5 white balls. So black, let me put the black
Black
balls.
and white. Black is 3/8, and 5/8. This is the white.
That's like the first one we did. Oh, that's messed up.
The same number but different questions.
Yeah. Okay. So now we need to answer the questions. What are the answers then?
You will put black and black.
Mhm.
It will be 3/8 times 3/8,
Which is
9/64.
okay, and this one.
It will be 25/64.
25/64.
Good. So how do we answer these questions now?
A is 9/64.
2 black balls. Yep. A. And what about B then?
B 24/64.
So 9/24. Add 15/24. Yeah.
Yes. Twenty-four over
24/64.
Okay. And then how did you work out C then?
55/64.
Which one? What's the answer?
55/64.
How did you get it?
Ms. Gladys, which one is the double white? Is the last one, right?
Which one is what?
No, the first one is black and black. The second one
Mhm.
is which one? Black and white or white and black?
A black one in the second row. This is the second row. So to have a black one in the second row is this one. It's black and black. To have a black one in the second row on this side is white and black. So you do this one, add, and then this one, and then add them together. Okay? That's just the language there.
What do you add exactly?
9/64.
No,
Add
I mean, I'm
50.
talking about C.
You're talking about what?
C.
Oh, you jumped to see. We haven't even talked. Wait a minute. Calm down. We haven't reached there yet. So I was still looking at this one and thinking, what are you asking me to do? Okay. So with C, at least one white ball. That's why I was asking. Who was answering? Was it Muad or
Mahmoud.
Majub? Oh,
Mahmoud.
Mahmoud. Yes, how did you get your answer?
I add up 15
Mhm,
over 64
mhm,
plus 15/64
mhm.
plus 25/64.
Well done. Yeah. So that's one way of doing it. You can, because it says at least one white. Okay. So any of them that has whites, you pick them. At least one white. But another way of doing it is, because you know that the total probability is equal to 1, you can do 1 minus the one that does not have it, 9/64. Yeah. And what do you get?
55/64.
That's another way to do it, okay? That's a much more efficient way to do it. Okay, but definitely you can do 15 over 64. Add 15 over 64. Add 25 over 64. Yeah, but you can still do it this way. Okay. Right. Adam, are you okay with the last answer I explained?
Yes, I understood.
Okay.
You have added all the numbers that has included white. So it's 15
Yes.
plus 15 and 25.
Yes. Okay. Now let's have a look at sampling without replacement, okay? We know how to draw the tree. So we need to know how to sample without replacement. I'm gonna minute, guys. I'm looking for my question. This is still sampling with replacement. Okay, so they are called dependent events, okay? So sampling with replacement. So the first one we're doing, we were doing sampling with replacement. Now we have to look at sampling without replacement, yeah? So this is without replacement. Okay, so you take the bead out of the bag, you don't put it back in, you don't replace it, yeah? And this means that one event is dependent on another, okay? It means that the event is dependent on another. So we call that dependent events. Okay, let's have a look at an example. You will understand this better when I do an example with you. Lucy has a box of 30 chocolates. 18 out of 18 are milk chocolates. And the rest are dark chocolates. She takes a chocolate at random from the box and eats it. She then chooses a second. Okay, we ended there. Question A. Draw a probability tree diagram to represent the information. And B, calculate the probability Lucy chooses 1. Two milk chocolates. Question 2. A dark chocolate followed by a milk chocolate. 3. At least 1 milk chocolate. Okay, guys, off you go. Oh, I haven't done it. I have to show you how to draw the tree, yeah? Because this is dependent. It's slightly different. Yeah, it's slightly different from how we've been doing the other one. This time is without replacement. She has a box of 30 chocolates. There are 18 milk and the rest of them are dark.
The first one affect on the second one?
Yes. She chooses from the box and she eats it. She does not put it back in, she eats it. And then she chooses a second one. Yeah. So let's draw the tree. So here we have milk and dark. Milk and dark. Milk and dark. Okay. So milk chocolate is 18 out of 30. So what will dark chocolate be?
12 over 30.
12 out of 30. Yeah. So if in the first draw, she chooses a milk chocolate, how many chocolates will she have left in the bag?
70.
29
29. So then it will be
over 17.
17 over 29. Yeah. But this one will still be 12, but out of 29. If in the first draw, she chooses a dark chocolate, how many dark chocolates would she have left?
11 over
11
29.
over 29. And the first one, the milk chocolate will still be 18 over 29. So now you know everything about the probability tree. You just need to answer the questions now, okay? So guys, answer the questions. All done? Yeah. Now it's slightly different from before. Oh, my chat is busting. Ah, Abdurrahman to everyone. You should be sending your answers to me, not to everyone. Goodness me. You just shared your answer to everyone.
Miss, you can't
Okay.
change it in the settings. Change it.
No, just click on the little corner on the side of the message and you see the download. You see the, no, I can't think of the word, okay? The little arrow that's pointing down. Click on that one and it will show you where you click everybody in the meeting or specific person in the meeting.
Make it only to direct to you.
Aha, well done. That's how you do it. Thank you. Okay. So what are we getting for the first one? Milk and milk is what? 18 over 30 times 17 over 29. These are going to be big numbers. What did we get?
51 over 100.
Is it? Oh yeah, 51
45.
over what?
145.
145. Okay. And this would be milk chocolate and dark chocolate. And that would be what? 18 over 30 times 12 over 29. And what's that then?
36 over 145.
And on the next set of branches, you have the dark chocolate and the milk chocolate. So that would be 12 over 30 times 18 over 29. What's the answer? The same as the above?
The same.
I would have thought so. And then the last one is dark chocolate and dark chocolate, which is equal to 12 over 30 times 11 over 29. And what's that then?
22 over 145.
22 over 145. So now you got all the three sorted. Now you need to answer the questions. Yeah. So we've done the first one to get the full marks. You got this one. You're definitely going to get a 3 in your exams, so prepare for that. Choose the probability that Lucy chooses 2 milk chocolates. What's that going to be then?
51 over 145.
Well done. Yeah. 2 milk chocolates is milk and milk, the first one. Okay. And number 2, a dark chocolate followed by a milk chocolate. So dark chocolate followed by milk chocolate will be what?
36 over 145.
36 over 145. At least 1 milk chocolate. How can you work this one out?
123 over 145.
Good. So you can do 1 minus 22 over 145, which is equal to 123. Oops. Over 145. So well done, well done, well done, guys. That's it with working at probabilities using probability tree diagrams. Yeah. After the break, I'm going to pick my daughter up from school at 3:30. So I will be back for 3:15, but I will leave at 3:30 to pick my daughter up from school. And I will be back at, I don't know. I just showed you, Muat, I just showed you the past paper, okay? So you can look at the past paper. Were you at the beginning of the lesson when I showed the past paper that is on Moodle? And there's 2 past papers there. So
sorry,
check them.
teacher. Next class, I will come from another device. So can you let me go and back again?
Yes, that's fine. Yeah.
Okay.
Okay, guys, if you have any questions. Why are you worried? You don't need to be. You don't need to be worried, guys. It's not necessary, okay? It's not necessary for you to be worried. Nobody, let me stop the live stream because I'm not going to teach you anything new.